Let's look at the common emitter amplifier. Common emitter amplifier. And in this diagram, the BJT is a small signal represented in a small signal manner. R pi or Rn, Gm, V pi is the voltage across the input resistance, and R0 is in parallel, Rc is there. So V pi is Vi, the open circuit voltage gain. V0 is minus Gm, Rc in parallel to R0. That is the output resistances, minus Gm into Rc. You could have RL also if a load resistance was connected to the output voltage. So you can say that AV is equals to minus alpha, total resistance in collector region upon total resistance in emitter region. That is a very simple formula to remember, that the whole voltage gain V0 by Vi. I'm not considering V0 by Vs. I'm considering V0 by Vi or V pi is equals to minus alpha, total resistance in collector region upon total resistance in emitter region, and Gv is equals to minus beta, total resistance in collector region upon total resistance in base region. This we are talking about common emitter. Why I have taken common emitter? Because common emitter is the most widely used amplifier. Now, earlier I told you about Re, R pi could be equals to 1 plus beta Re. This is the scenario where it actually happens. The amplifier input resistance Rin is given. Then Rn is equals to 1 plus beta Re plus Re. Re 1 plus beta Re. One is with included Re and other is without Re. With AV0 is equals to V0 by Vi minus G to Rc in parallel with R0 minus Gm into Rc upon 1 plus Gm into R. With emitter resistance it becomes this, and as we already discussed, AV is minus alpha into total resistance at collector region upon total resistance at emitter region. I think I have forgotten about putting this equation here too. Okay, so it becomes like this. Now it's perfect. Then AV, GV. Look at these equations carefully, remember them well, because you will be asked. It has happened many times that an common emitter amplifier with emitter resistance has come, or simply a common emitter amplifier has come. Now, one needs to calculate by himself how to get the value. Okay, AV0 is minus Gm into Rc in parallel with R0, 1 plus Gm into R0. Simply it could be minus Gm into Rc divided by 1 plus Gm into Re. As this Re is degrading the whole gain, that's why it is called emitter degeneration resistance. The input resistance is increased by this factor 1 plus Gm into Re. The voltage gain is reduced by this factor 1 plus Gm into Re. The overall voltage gain is less dependent on the value of beta. And that's a good point, because beta is a quantity which changes with temperature. And if that changes with temperature, then it is sensitive to the change in temperature, which will affect our normal working of our device. And for not having to reduce that effect, we attach a resistor at the emitter, and with the decrease in gain, but we make the whole circuit gain beta free. Okay. Now the